Hey everyone, and welcome. Today, we're diving deep into the absolute heart of any virtual infrastructure, the vSphere virtual machine. Now, we've all been there, staring at that massive official admin guide, right? Well, we did the hard work for you. We've pulled out the most critical info, the essential steps, and even some of those surprising little tips that are buried deep inside. Okay, so let's just kick things off with a super simple question. We throw the term VM around all the time, but have you ever stopped to think about what one really is? What's actually going on inside that computer inside a computer? And here it is, pretty much in a nutshell. A VM is just a software version of a physical computer. It is the fundamental building block that lets us take one great big powerful server and slice it up into a bunch of smaller, completely isolated systems. So let's get into our first section. What is a virtual machine? The computer inside a computer. And what's so interesting is that it's way more than just a simulation. It has its own distinct parts that really matter. A VM has its own proper virtualized hardware. It's got a virtual CPU, virtual memory, its own virtual disks, and network adapters, just like a physical box would. And the really crucial point here is that these resources are being pulled from the underlying physical host on the fly, getting allocated and deallocated as the VM's needs change from moment to moment. Okay, so that's the what. Now for the how. How do you actually, build one of these things? The admin guide makes it super clear that there isn't just one single way to do it. So in our second section, we're going to explore the different paths to creating a new VM, because each one is really for a different situation. Well, the most straightforward way is just using the new virtual machine wizard. It walks you through the initial blueprint, you give it a name, you pick its home on a specific host and data store, and then you make a really critical choice, the VM hardware version. And this decision actually has a huge impact on what features you can use and which hosts it'll be compatible with down the road. But let's be real, creating VMs one by one from scratch, nobody has time for that. It's incredibly inefficient. That's why the guide dives into much better methods. Cloning is the simplest. It's just a direct, one-off, exact copy. But for true, repeatable standardization at scale, you're going to want to use templates. You create one perfect master image that you can then use to deploy dozens or even hundreds of identical, pre-configured VMs. And look, when it comes to deploying from templates, the guide basically screams this one thing at you. VMware Tools is non-negotiable. It's the magic sauce that lets vCenter automatically customize each new machine, giving it a unique name, IP address, and joining it to the domain. And get this, the guide even tells you the exact log file paths to check when that customization process inevitably fails. Now, besides templates, there are a couple of other common ways you'll see VMs get created. You can deploy from an OVF, an open virtualization format, which is perfect for those prepackaged application appliances you get from vendors, or you can do what's called a P2V, or physical to virtual conversion, to finally get that old physical server into your modern virtual world. And this whole P2V thing has a really fascinating detail the guide points out, this idea of a confidence metric. See, the tool analyzes the old physical server's performance to recommend the right size for the new VM. And the key takeaway is that the longer you let that analysis run, sometimes for up to a month, the higher the confidence score, because it can capture performance spikes from things like month-end financial processing that you'd otherwise miss. All right, our VM is built. Now for the really fun part, all the knobs and dials you get to play with to tune this thing for performance and give it special capabilities. So, one of the first big decisions you gotta make is about storage. A standard virtual disk, or VMDK, is just a simple, self-contained file. Easy. But a raw device mapping, an RDM, is a different beast entirely. It's basically a pointer file that maps your VM directly to a physical storage LUN. You're trading a bit of that simple flexibility for some raw, direct access to the hardware, which is absolutely crucial for certain things, like specific server clustering setups. Now, if you really want to squeeze every last drop of performance out of a VM, the guide points you to two specific adapter types, PVSESI for storage and VMXNet3 for networking. They're called para-virtualized, which is just a fancy way of saying they were designed from the ground up to work inside a virtual world. The payoff is huge. You get way higher throughput with less CPU overhead. The only catch? Your guest operating system has to have the right drivers to actually use them. And this right here is one of those golden nuggets you find deep in the admin guide that can save you a world of pain. You might think, great,
I'll use that high-performance PVS CSI controller for everything. But if you try to make it the boot controller for a Red Hat Enterprise Linux 5 machine, it's just not going to work, period. You have to use a standard controller for the boot disk. This kind of specific detail is absolutely priceless.
And hey, speaking of booting, we've all been there, right? Mashing the F2 key, frantically trying to get into the BIOS before the VM boots up in half a second. Well, the guide points out these incredibly useful, simple options. You can just add a boot delay, or even better, just check a box that forces the VM to go straight into the setup screen on the very next reboot. It's a total lifesaver. Okay, so the VM is built, it's tuned. What now? Well, now we move into section 4, the day-to-day stuff. Beyond that initial setup, the guide highlights a few key tools in your toolkit that you're going to be using constantly to manage these things.
Let me ask you this. Have you ever wished you had a giant undo button for an entire server right before you install that sketchy new software patch or make a risky configuration change? Well, in the world of vSphere, you actually do.
It's called a snapshot, and it's exactly what it sounds like. It captures the entire state of a virtual machine at a single moment in time. We're talking memory, settings, and all the disks. It's like hitting pause and saving your game. If your update goes completely sideways, you just click a button and the entire machine reverts back to the exact moment before you started. But, and this is a huge but, there's a massive gotcha that the guide points out. If you've configured any of your virtual disks as independent, they are completely 100% excluded from snapshots. That means if you roll back the snapshot, that disk just keeps on going like nothing ever happened. You absolutely have to know this and plan for it in your rollback strategy. Okay, but what about modern apps? They aren't just one server anymore, right? You've got a web server, an app server, a database. They all have to work together. For that, the guide explains vApps. Think of a vApp as a folder, a container, for all the VMs that make up a single application. It lets you manage them as one logical unit, and you can even control the specific order they power on, which is super important. All right, so as we start to wrap this up, let's pull back for a second. Because when you read through the whole guide, you start to see this one big idea, this one constant theme pop up over and over again. And it's this fundamental balancing act between abstraction and reality. This, right here, is really the fundamental challenge of being a virtualization admin. On one hand, virtualization gives us this amazing, clean layer of abstraction that hides all the messy hardware details. But on the other hand, to get real performance and avoid weird compatibility issues, the guide shows you have to pay extremely close attention to how your virtual parts are interacting with that very same physical hardware. So you end up living in these two different worlds at the exact same time. There's the beautiful, simple, clean abstraction of virtual CPUs and virtual desks, and then there's the messy, complex reality of physical CPU models, NUMA nodes, and super specific hardware drivers. Mastering vSphere is all about learning how to live in both of those worlds and navigate between them effectively. And so that really leaves us with one final thought to take away from all this. Knowing that you constantly have to perform this dance between the clean abstraction of a VM and the complex reality of the hardware it runs on, how does that change the way you think about designing and managing your own virtual environments?